Welcome to Matt Explains Science. This is the second lesson in the General Chemistry course. Today we will be following on from the classification of matter lesson by looking at the three states of matter. So let's get started. Most of us have probably learnt about the three states of matter to some degree in school, so this should be familiar to you. But we will remind ourselves about what the kinetic molecular theory of matter says and how it relates to the three states of matter. So, firstly, matter consists of particles and they're constantly moving and vibrating. All particles have energy in the form of kinetic energy, which allows them to move. As an object is heated, the particles that compose it gain more energy and move faster and faster, until finally they have enough energy to break free of the bonds holding them together. So how does this relate to the three states of matter? Well, as the temperature increases, so does the average kinetic energy of the particles of the object. When the temperature is low, so does the average kinetic energy of the particles, and they remain in a fixed position. The object therefore remains in a solid state. As the temperature increases, the average kinetic energy of the particles also increases, allowing for the particles to move around each other more in a liquid state. And finally, when the temperature has increased enough, the particles have gained enough kinetic energy to break free from the bonds that hold them. The object has transformed into a gaseous state. Let's look at these three states in a little more detail. In solids, the particles are packed closely together. They have a fixed volume and shape. Particles move but can only vibrate in a fixed position. And finally, the forces between the particles are strong enough to keep them fixed together. As for liquids, the particles are still close together and they are still in a fixed volume, but the shape is not definite. Like water in a glass, the volume is unchanged, but the liquid takes the shape of the container that it's in. This is because the particles are vibrating, rotating and moving around one another, but the forces are still strong enough to keep them together. As the temperature increases sufficiently, the liquid turns into a gas. The particles are dispersed in a random motion, with no fixed shape or volume. This is because the particles have so much energy that they are moving so quickly and the forces between them are not strong enough to keep them together. So the changes between three states of matter have specific names. When a solid is heated, it will firstly be converted into a liquid. This process is known as melting or fusion. Then once the liquid reaches its boiling point, it will be converted to a gas in a process known as vaporization. The opposite process is when the particles begin to lose heat to the environment and cool down. Firstly, from a gas to a liquid is known as condensing, and then from a liquid to a solid by freezing. There are two more processes which you may or may not have heard of. The first is when a solid is converted directly to a gas. This process is known as sublimation. And the opposite process of turning from a gas to a solid is known as deposition. So really, the three states of matter depend on both temperature and pressure. This is a basic phase diagram, and it represents the relationship between temperature, pressure, and the state of matter. Every substance has its own phase diagram, some simple and others more complex. It is important to note here that every substance has a triple point, the point at which a substance is in thermodynamic equilibrium and can exist in a solid, liquid, and a gas at the same time. In the case of water, its triple point is at 0.0075 degrees Celsius and a pressure of 0.0061 atmospheres. So at very low pressure and just above 0 degrees Celsius, water will exist in its three states simultaneously. At temperatures and pressures below the triple point of a substance, the liquid phase does not occur, and it is in these conditions that sublimation and deposition can occur. That's all for today. Thanks again for watching. Stay tuned for more content and please like and subscribe.